Hello, welcome to our lesson Echo. We are already on letter E for Echo. And so in lesson Delta D, we have learned how to translate parabola and reflect. Okay, so let's just summarize. So when your equation has a plus here, plus any number, and that means you will translate or move your parabola n units up, whatever that number is. Okay, minus n, that means be n units down. Now if the n is inside the parenthesis and if it is plus, then that's a horizontal translation, right and left. This one is vertical translation, up and down. So here, remember, if it is plus n inside the parenthesis, that will translate your parabola n units to the left. If it is minus inside, whatever number is n, that will translate it n units to the right. Okay, how do you reflect a parabola? So, when you see a negative, okay, negative here, that means you have to reflect across the x-axis, or you have to flip it across the x-axis. Okay, and I hope you did well also on your homework. So now our new lesson is how to stretch vertically. Vertical stretch and vertical shrink our parabola. So when do you know when you have to stretch? When the number here, okay, when your x squared, or when your parabola is multiplied to a number which is bigger than 1, this n is any number bigger than 1, that means you have to stretch it that many times. Because sometimes you can stretch not so hard, sometimes you have to stretch so hard, So how do I stretch? How much do I stretch? And this number will tell you. Okay, so if n is bigger than 1, example, if you have to, they ask you to graph y equals 4x squared. That means you have to stretch it with a force of 4. Okay, and that will be more stretched than one that is let's say 2x squared. Okay, so these are both stretched, but this one is stretched by a force of 2 and this one is by a force of 4. Okay, in math you don't say force, you say factor of 2 and a factor of 4. Okay, if that is bigger than 1, then you stretch. Now if the number here in front, or your coefficient here, is a number between 0 and 1, okay, 0 and 1, let's say 1/2, 1/3, 1/4, 2/3, okay, so that means you shrink it. Okay, so example of this, like we said, is y equals 1/2 x squared. That will be a shrink. Okay, or y equals, let's say, 1/3 x squared. So this is the force. How much do you shrink it? This is factor of 1/3 and this is factor of 1/2. Okay, so let's study how to stretch first a parabola. Okay, so let's study how to stretch. Let's just use one factor. Okay, let's just say we are stretching with a factor of, let's say, 3. Okay, so 3. So this will be stretched with a factor of 3. It could be any factor bigger than 1. Okay, for to study the shrinking, we'll just use the example factor 3. So if you stretch a parabola, basically you're stretching points. Okay, so let's just study how to stretch one point with a factor of 3. Okay, so let's talk about this point here. Let's just say, okay, that is your x and y axis. Okay, so this point here, so listen, pay attention. So look at how far is this from the x-axis. From the x-axis, okay? So you see the distance of the point from the x-axis is 1 unit. 1 unit. Now you're going to stretch it or pull it up away from the x-axis, away from the x-axis, from this line by a force of 3. Okay, a factor of 3. So this is what you do. You measure the distance of the point from the x-axis here, okay? So it is this one here, okay, one distance. You're going to multiply that by 3, okay, 3 times. So you're not going to start here. You will start here still. So 1, 2, and 3. You are not translating, okay? You are not translating. You are stretching, okay? So this one will now be the new point, okay? So this one will be the vertically stretch. When you vertically stretch this by a factor of 3, it will be here. Okay. What about if the point is here? Okay. How do you vertically stretch it away from the x-axis going up with a force of 3? Can you answer that first? Okay, pause the video. Where will the new point be? Okay. So, I'm going to measure the distance from the x-axis, that is 2. Okay, I'm going to multiply that by 3. Okay, or I'm going to do 3 times this much. 1. I'm not using this because you might think that is translation. Okay, we are not translating. So 1, 2, and 3. It will be here. Okay, instead of 2, it will now be 6. 1, 2, 3, 4, 5, 6. Okay, so this one is stretching this point by a factor of 3. Okay, what about if it is this point? Let's say here, or let's say it's here. Where will be the new point? Okay, let's say in the middle, 1/2 here. So where will that point be? Okay, so 1/2, another 1/2, and another 1/2. Okay, 3 times. Okay, so that is the stretch of this point by a factor of 3. Let's try again, factor of 3. So what about if the point is here, 1/2? Let's say 1/2 here. Where will be the new point? Okay, so I'm going to measure 3 1/2, right? So 1/2, 1/2, 1/2, and another 1/2. It would be there 3 times factor of 3. You pull it up. Are you getting it now? Okay, so that's 1, 2, and 3. What about if the point is below the x-axis? So let's say here, if the point is here, you will pull it away from the x-axis. So away is not like that. You're going towards the x-axis. You're going to pull it away, now down, okay? By a factor of 3. So this is 1, 2, another 1, 2, and another 1, 2. It will be here. Okay, that is stretch by a factor of 3. We're only using factor of 3. Okay, and the last one, let's say you have another point. Say you have another point. Let's just try maybe here, 1/3. If you have a 1/3. Okay, 1/3. How will you below the x-axis? So 1/3 by a factor of 3. So you will stretch it 1, 2, and 3. It will be here. Okay, if that is 1/3. Okay, I hope you know how to stretch, okay, by a factor. And I'll see you on the next video. I'll see you in the next video.